Hi, this is our interim presentation for ME452 by Team 10. The part we chose was a coffee pot, which is a device that allows for freshly brewed coffee in various serving sizes. This product works by heating water from a reservoir and then dripping the hot water over coffee grounds into a filter basket, thus extracting the flavor into a coffee pot. Primary customers are office spaces and various event spaces. Office spaces that have coffee available for their employees prioritize coffee pots that are easy to clean, offer large batch sizes, and are cost effective. Event spaces such as restaurants, boutique stores, hotels, and premium lounges are also primary customers because they seek to complement their services with quality and efficiently prepared drinks for their customers. Secondary customer groups are individuals who are frequent coffee drinkers. Individuals who buy coffee pots for their households prioritize quality, cost, ease of use, and individual serving sizes. Our annual estimated demand is 17,480K units, which includes both residential and commercial. Our estimated production volume is 363.6K units. And here is an exploded view of our assembly CAD, which includes 18 different parts.
The task function of the coffee machine is to brew coffee. Its primary basic functions include heating water by adding heat, filtering coffee by dripping water through the grounds, dispensing the drink by guiding flow and controlling volume, maintaining temperature by warming the coffee or stopping the heat, and handling waste such as draining excess water. The primary supporting function is to make the process more convenient and dependable, which is achieved by regulating the heating module's temperature. Additionally, the machine enhances the product by reducing noise and please the senses of the owners by improving in aesthetics.
Getting into the fishbone assembly sequences. The first fishbone assembly sequence is you begin with the bottom shell, then you add the heating plate and heating module, then the bottom plate, controller, and cable assembly. From there you move to the kettle body, kettle strip, kettle handle, pot lid, then the water tank, water pipe, filter tank interface, then the container lid, then the filter container, filter holder, filter, and finally the water tank lid. The second fishbone assembly sequence involves the bottom shell, the heating plate, heating module, bottom plate, controller, cable assembly, the water tank, water pipe, filter tank interface, container lid, filter container, filter holder, filter, the water tank lid, and finally the kettle body, kettle strip, kettle handle, and pot lid. Analyzing the two sequences, it comes to show that sequence 2 has a higher, easier transfer and handling of components, as well as it's easier to assemble parts in parallel.
This chart of function component mapping matrix illustrates and helps us better understand the functional relationship between the components and design goals of the coffee machine. Across the top, we can see the key functions such as adding heat, dripping water, containing ground, controlling volume, and etc. And for the first column, we can see the components that builds up to make this coffee machine. So across the chart, we can see how the water tank lid has the purpose of controlling volume, draining water, ensuring convenience, and enhancing aesthetics. And for the section of container, we can see the container lid has the purpose of containing ground and assuring convenience. So across the whole chart, we can know the purpose and importance of each component and how we can improve the design of this coffee machine.
This slide shows our bill of materials. Our design includes both injection molding parts and sheet metal working parts, with a total estimated cost of about $28.31. For reference, most office coffee machines cost around $60 to $90, meaning our cost is less than 50% of the typical retail price, which makes it a reasonable estimation. Next, for the core chart, we'll analyze which components contribute most to the cost and focus on parts we can actually redesign in the future DfM and DFA phase. So we will redesign the filter holder, heating plate, and water tank.
Now, let's talk about product family design. The function that we believe creates a point of differentiation between our two customer segments is control volume. This essentially means that the amount of coffee prepared and stored for our customer groups will be different. Customers who use this machine in offices, co-working spaces, restaurants, lounges, etc. will want a larger amount of coffee stored in the pot compared to users who will use this machine for individual needs in homes. On this basis, our modules are defined by the components within the kettle subassembly: the kettle strip, pot lid, and the kettle body. For cost and manufacturing effectiveness, we do not modify the kettle handle, which is able to support both variants equally well. Here, we have an updated CAD model for the kettle module, which shows a redesigned kettle with a reduced size to serve the needs of customers who purchase this for individual use.
Here you can see our assembly sequence. In our original assembly sequence, we didn't have divergent parts till the kettle body, then the kettle strip, kettle handle, and pot lid. But since there's only one variation of the kettle handle, in our revised assembly sequence, we decided to move this up before the kettle body, kettle strip, and pot lid.